sort of signalled opportunities. How does that relate to the work that I want to do on my farm?
Okay, this is no definitive list, and it's just one way of looking at it. But what we've tried to do here is group the 3 signal strengths into 3 categories: low, medium, and high. And what we said about the low ones, they're generally the free signals. So they're the EGNOS signal, which is a kind of meter accuracy, the John Deere SF1, which is about 1 foot or 30 centimetres, the OmniStar VBS one as an example. And we're going to use those for things that perhaps traditionally, maybe in the future this might change, but we haven't needed lots and lots of accuracy. We just needed some basic, straightforward guidance. So maybe some of the extensive tillage applications, or lime spreading, slurry spreading, maybe spraying once your tram lines have been established using a more accurate system are good examples of when we might use a lower accuracy system. Then the medium level accuracy system, these are the satellite systems that you probably pay a prescription for. The John Deere SF2 system, the OmniStar HP system and things like that, you'd use certainly for spraying, certainly for certainly pre-em or where you can't see the tram lines yet anyway, mowing, drilling, harvesting and those sort of applications. And then the high level accuracy, we're talking about RTK principally here, we're looking at where we really need lots and lots of accuracy. So planting, when you're involved in bed systems, or when you need a lot of repeatability, such as the controlled traffic farming application, or sometimes when someone has a large fleet of tractors and they don't want to pay individual licenses for the receivers, then the RTK can overcome that problem.
You mentioned some subscriptions in amongst that little lot. What are the subscriptions and how do they work? Okay,
we can provide prescriptions to gain more accuracy. So if you want to go to a more accurate satellite-based system, then you pay a prescription. But the good news there now is we can pay that monthly, quarterly, or annually. So if, generally speaking, what a lot of people do now, if they want a high level of accuracy for, say, the harvesting application, for drilling, and through the crop establishment period, they buy a license for, say, 2 to 3 months. And then they let that license run out and it defaults back to the lower level accuracy, and by that time the crops emerge, you can see your tram lines, and of course then you've got the inherent accuracy within the field itself.
Is it easy to get hold of those subscriptions? Do I have to book a few months in advance, or is it a bit quicker?
No, straightforward, credit card over the phone.
Right, and somebody else taking credit cards. What do you mean by always on there, under the high level accuracy?
Okay, with RTK, and we're not talking about the way we're providing it through a mobile phone network here, but through the more traditional sense of having a base station, then you're not paying any monthly subscription or any money license. You've paid a bigger capital cost to get RTK on your farm, but once you've paid that capital cost, the ongoing costs are negligible, really.
So in theory, I can just extend the fleet of tractors or equipment that I've got around this system, and it's not going to cost me any more money.
No, in theory, there is no limit to the number of machines you could use on one base station.
That's interesting. Okay, based on all of that, where should I be starting? Where am I going to get the most advantage from?
Okay, I think it's fair to say that guidance technology today is being used in a very wide spectrum of applications, and it will bring advantages pretty much everywhere you use it. There's no place that it won't bring substantial advantages. But I think we've all agreed, really, drilling is the key operation. Okay, if you can establish your tram lines in the correct place, then all the subsequent operations get that inherent accuracy. And this is an example of perhaps where guidance hasn't been used, I would suggest. And it's a picture taken this autumn, so it's not very historic. It's taken this autumn in emerging winter wheat. And you can see several things about this. First of all, the tram lines aren't parallel. Okay, so that's going to create problems. And secondly, there's over 10% overlap in every drill width. It's a fairly narrow drill width, but you can see the dark green strips up and down the field where you've got a substantial amount of overlap. And it doesn't take me to tell you, Ian, how much that could potentially cost as you go throughout the whole season and apply all your chemicals in your fertiliser, just how much that's going to really cost.
Yes, thankfully that isn't my field. So what are the benefits are from starting off with drilling and getting that right?
Okay, so we arguably probably agree that drilling is probably the most important operation as far as guidance is concerned. And you've probably guessed most of these already, but it's important that we get the tram lines in the correct place. It's preaching to the converted almost, but if we get the tram lines in the correct place, then the savings are throughout the whole season, really. It's important that we get the tram lines both in the right place, but also parallel as well, and the advantages goes without saying there. And the whole thing reduces the amount of overlap on every single operation. And importantly, over time, it will certainly reduce your seed cost straight away. But as you get to know the field size and they become more accurately measured through GPS technology, you'll find that you're putting less fertiliser and less spray as the years unfold. It may not happen at day one because you're going to put the same spray as you always have done for that field, but then you'll realise you're probably using slightly more than you were, or slightly less than you used to.
Well, I reckon I'm pretty accurate. Myself and my operator, we're both pretty good at getting our tram lines right. So what can all this do for us?
A field that we've looked at, and anybody can do this. This is a simple Google map. It's available to everybody. All they've got to do is look at their field, and you can download this map. And it's good to do that. It's good to see from an aerial point of view what you're doing. So there's no cost attached to this exercise, and it's pretty basically available to everyone. So it's a good way to start. And this is one of your fields. It's a typical field size of 12.6 hectares, and it's got a 300-metre headland, and it's 420 metres long. And at the moment, in that particular field of oilseed rape, we've roughly worked out about 13 tram lines.
Yeah, well, I would agree with that. That's not too far off. I'm not sure how much more my accuracy can improve, but you probably suggest I might be able to make a little bit of a difference.
I think in this case we've picked a field and we picked a situation that actually you're doing a pretty good job in. So if we have a look at what you're actually doing now, then your effective drill width, if we actually go and measure it in the field as we've done, is 5.75 metres. Remember, you have a 6-metre drill, yeah. But your effective drill width is actually 5.75. So you're losing a little bit of your drill width because of the overlap. And that's making your tram lines about, give or take a few centimetres, about 23 metres. And that's not untypical. We often go and measure tram lines and you can find, say on a 24-metre sieve, often the tram lines are 23 or even less than 23. There's an awful lot of overlap out there. And you might think that represents a lot of overlap. You know, I've already talked about 10%, but actually in your application you're doing a pretty good job. It's only 4% when you measure it.
Yeah, so we're pretty good. So that's not too bad at all. So that's on no guidance. Have you got anything that would show me if I started to get a bit more accurate through using the technology, what it might mean? So
if you use a kind of SF2 or a medium level accuracy system, then we'd expect the effective drill width go up to about 5.9 metres. We'd lose potentially the maximum of the 10 centimetres. And that would take your effective tram lines up to 23.6 and take your overlap percentage right down to 1.6%.
Right, yeah, that's pretty good. That's on the medium system. What about the RTK system?
And RTK, really, we're taking the drill width right up to its effective size, so we're basically 6 metres. You're taking your tram lines more or less up to 24 metres and taking the overlap down to a negligible amount, really.
That's all very well and good, but is it, what's it going to mean for me in that field? Because yeah, those figures are okay.
Okay, well, let's look at that field again. If we take that effective drill width of 5.75 metres, we're going to do a really simple sum here. We're just going to take the 300-metre headland across the width of the field there, divide it by 5.75, and it's really giving us about 13 tram lines, which we know already because we can actually see them from the aerial picture, but it effectively means you've got 52 drill widths in that field.
Rightio, so taking it on then the next stage, what does that mean in that field?
All right, so what it means in that field, if we increase our effective drill width up to 5.9 metres, we again do our simple sum of taking 300-metre headland, divide it by 5.9, you've now only got 12.7 tram lines. That might not really excite you because a fraction of a tram line might be fairly meaningless, but what's really important here is we've taken one complete drill run out of that field. Yeah. So we've gone from 52 rather, down to 51.
Rightio, and so we put it onto an RTK system. What does it mean for that field?
Okay. Sums work out quite nicely for us. So we've effectively taken our drill width up to 6 metres. Again, you take the 300, divide it by 5.98 or 6 metres. You're down by half a tram line. Again, that might not mean too much to you, but the important thing there to remember is we've now taken a further drill run off. So we've gone from 52 down to 50 drill runs. And it doesn't take me to tell you, by taking a whole drill run of fuel, time, seed cost, etc., just what some of the costs might mean.
So on that basis, if we're looking at money, what will it mean in that field and across my farm? Okay,
let's just look at some of the simple costs and see what that might mean in terms of pure economics. If we take our manual or no guidance or where you are now, you've got a 4% overlap, an effective drill width of 5.75. What it really means is you're actually drilling 13.1 hectares. Instead of drilling 12.6, the field size, you're over drilling more of the field than you have to. Then we've got to a medium level accuracy system. We take our overlap down to 1.6%. Our effective drill width goes up to 5.9 metres, and now we're effectively drilling 12.89 hectares. And then with the RTK system, we're really up to 6 metres, and we're really drilling the field size at 12.6. And if we look at 3 key costs, the cost of fuel, which is one that most people look at, the cost of labour, and the machine value, then, and these figures are taken from the HGCA research document that you'll learn more about later on this afternoon, then we're saving in that field about £75 with the medium level accuracy system, and around about £100 with the high RTK system.
What happens, yeah, if we sort of put the other inputs into there, what effect will that have? Okay,
so if we look at some of the bigger costs, I won't go through all the figures that are greyed out there. That's a repeat of what we just looked at. But if you look at seed, for example, and again the figures are taken from that research document. The seed cost at £54 a hectare, then it's costing you about £707 to drill that field at the moment with the 4% overlap. If we take that down to 1.6% overlap, it's costing us about £10 less, and about £25 less if we go to the RTK situation. So not huge savings there, but there's some savings there. I think the bigger savings now, if we look at nutrition costs. So if we say the total nutrition cost for NP and K is around £252 a hectare, give or take an amount, and again you can see how that's established in that document, then you can see that the cost savings are bigger. So if we go from where you are now, you're spending about £3,300 on your nutrition costs. We can take about £50 out of that if we go to the medium level accuracy system, and about £150 out of that if we go to the high-end accuracy system.
So putting those two lots together, what does that mean across my farm?
Well, if we add both the fuel, the labour, and the machine value plus these costs here, then the savings get quite considerable. And if we look at it from, you can see there the fuel and the variable cost, the total for that field savings are £138 with the medium level accuracy system and nearly £250 with the RTK system. And if we project that right across your 500 hectare farm, we've just done a simple sum. I know in reality it's not quite so straightforward as that, but I think it gives you an idea of nearly £5,500 saving across your farm in one season, or nearly £10,000 with the RTK system. You quickly get quite a lot return for your investment. And we haven't looked at all the savings. We've only looked at a few of the savings here.
Well, that's pretty much a no-brainer. What do I need and how do I start? Because I want it now.
Good, I've done a good job on you. Okay, well, basically the first thing you have to ask yourself is I need a receiver. You can't operate any of this technology without some sort of receiver, and there's a number of receivers on the market, and the level of sophistication will depend on what you really want to do. But for example, we're looking at drilling here, so we need some good level of accuracy, I would argue. And the 2 key questions you need to ask yourself is, can it receive L1 and L2 signals? Is it a dual frequency satellite receiver? And the second question, has it got terrain compensation? We'll touch on that in a moment, but those are the 2 key questions you need to ask. And if it hasn't got either of those, and you're doing quite accurate applications like drilling, I would suggest it's not worth the investment of your money in that. Obviously you need a display, and displays come in all sorts of shapes and levels of sophistication, and right from a simple light bar system you see on the left hand side there, right through to the more sophisticated colour, touchscreen colour displays. You pay your money, you take your choice. The only thing I would suggest there, if at any point you're doing anything to do with mapping or documentation, then I strongly urge you to look at the colour screens, because that gives you a much better interface in the cab when it comes to mapping. And then to actually make the steering work, if you've got an older machine that's not equipped with the kind of all the components that the modern machines are, you'll need some component that allow steering to take place. You can have digital motors that strap onto the steering column and harnesses. And then on more modern machines, you have it all incorporated. So you have the electric valves, the harnesses, and the sensors needed to make it all operational.
On this one, do I have to have it on a new tractor? Do I have to buy a new tractor, or can it be retrofitted to...
No, it can be retrofitted. It depends a little bit on the age, serial numbers and things like that, but a lot of this technology now will retrofit on older machines, yeah. I
was getting very excited about buying it straight away, but there's different colour boxes and receivers up there, and do they all work together, and will it work when I want it to work?
Yeah, I think today a lot of things do work together, but I think it's very critical when you're asking yourself a question to do the research, ask the experts, and make sure you do your homework well before you make any purchases.
So having a good conversation with a dealer or whatever to make sure it
Absolutely,
works.
yep.
It's there. You mentioned something, terrain compensation. What's that all about?
Well, it's simple. I think most people appreciate if you're working on any slopes, it's an extreme slope, but if you're even working on gently undulating land, the receiver will not be in the centre of the tractor anymore. And so we need to work out what that means really in terms of in the field, and simple gyroscopes in the bottom of these receivers will allow us to work out what the correct location needs to be for that machine, whether we need to go up or down the slope to compensate for that terrain.
So that's an essential piece of the equipment.
Yeah, most good receivers will have that as standard, but you need to make sure that that's there.
Rightio. So at the moment we've just been talking tractors. Where else can I put this sort of technology?